Good morning. I tried to go to our classroom again. I couldn't get the internet to work, so then I had to rush back to my office. So now I'm in my office, and my apologies if you were trying to join in person. I only saw one person there, but still, if you showed up to our room and I wasn't there, it's because I couldn't get the internet to work. So my apologies. I'll say the internet is not working, or I'll say is still not working. Yeah, and everyone just says, no, if I can join online, I'm going to, because I don't want to get COVID. I know, that's smart, actually. So is still not working. In our classroom. So I'll have to, and I'm getting these direct messages, but I think it'd be really nice if you send to everyone so that everyone can see them, unless it's a personal issue just for me, but then everyone can kind of join it. Okay, so I'm a little bit thrown off because here I am. Okay, we're starting class. What I did was I did post for this reason. I posted a poll on Moodle, on our Moodle page. Where is it? Oh, well, I also posted a video that I really like that I refer to later in the course. So it's funny. It's from Superstore. If you haven't watched Superstore, it's a funny show, and there's actually lots of stats humor in there, so pretty funny. But anyways, so you can watch that video. And I can't do this poll, but how can I see the question that I asked? How can I show it here? You know what? What if I switch to being a student? See what it's like on your side of the pond. Let's see here. So I did post, and maybe I'll make it bigger here. Done. Saved photos. I'll bring it into our notes here. Kind of crop top this here. Can be way smaller. Okay, so for planning purposes, what I mean by that is, do I need to find another room? Need to book another room? Or should we just proceed online? Since everyone is, we've got one vote for online. So I just wanted to see, since everyone has been joining online anyways, I just wanted to see if that's what everyone wanted. So if you could put your preference on the Moodle quiz, that would be great, or it's a Moodle poll, I guess. Yeah, so I kept it nice and simple, okay? And so I would like to know how you anticipate attending class this term. So this is not, for every class, but how do you generally anticipate joining class? Because, and then I kept it nice and simple. Either you plan on being online, or you really want in person, then I would, I'll book a different room, or I'll see if I can book a different room. And then some people do neither, right? Don't come to class, but you'll watch the videos after class. just so I know what to anticipate, okay? Because especially if we're gonna do in person, then there's a couple of things that I would like to know. For example, how many people should I be booking a room for? Because it doesn't seem like it needs to be for the entire class. So today I'm joining from my office, and luckily no one's in here. So otherwise it can be kind of a busy place. So I'd love it if you could complete this poll by midnight tonight. By 11:59 tonight, please. Oh yeah, yeah. Then if you're in a way different time zone, then yeah, probably watching the videos after is probably a good idea. Then you can watch them with your whole mind, not half your mind. Yeah, definitely. So, and I did update. There's only one video there, but let's see here. I did update our link to the lecture videos on YouTube. We only have one so far, but I'll post today's there. And so we'll keep building it up. Or if you wanted to skip ahead, you could watch last term's. We're gonna do basically the same thing. Okay, so there's the quiz here. I don't have a pointer when I'm online here, but the course delivery mode, that's the poll that I want you to do before midnight tonight. Okay. So today I want to start chapter 1. Now, hopefully, you know, you've kind of flipped through the textbook a little bit. Chapter 1, we go through and we establish just some key terminology, and that's what I want to focus on today. And then just for simplicity's sake, I will be posting just a video for tomorrow for you guys to watch on your own time. Okay, just because this whole internet fiasco is not fun. So just to keep things simple, tomorrow's class will be a video that I post, a video posted for you to review or for you to watch on your own time before Tuesday, right? Kind of let you plan your weekend, okay? So that way I can see if I can get a room booked or what we need to do. So I'll kind of wrap up this chapter in the video. Whatever we don't get through today, I'll wrap up in the video and you can watch it on your own time. Okay. So I also saw that a lot of you had already submitted your Markdown test document. Oh, I'm in student view, so I can't see how many, but make sure that you submit that. I think it's due at midnight tonight. So much due at midnight tonight, so busy. But they're all just little tiny things. So that's why I'm keeping it nice and short, not drawn out. Okay, so make sure that you submit your Markdown test document. You guys are all, I think, pretty well all of you are in data science. So you probably have R and RStudio and LaTeX all installed. So you don't have to use the cloud version, but you can if you want to, because then it's all set up and you don't have to install it on your computer. RStudio Cloud is relatively new, so I don't think anyone's using it yet, but it might be fun to play around with for you guys. Okay. So let's see here. All right. So, no, so if you download LaTeX, you don't have to connect it with R. You can just, as long as it's on the same machine, it should be able to produce a PDF. Okay. And I'm happy to kind of meet online with anyone who wants help getting it all set up if you want it on your own machine, because it can be really tricky, right? But it's often better if we just do it kind of one-on-one. So, but I'm available pretty much all the time, except for after this class. Then I have another class, but just let me know if you want help. But if you download a LaTeX distribution, so there's a couple of options that it gives you. And then, okay, so it says it doesn't have LaTeX. It might be in the Sweave options. So yeah. Yeah, let's try to meet up and we can get it sorted out. Because if you have it downloaded, then it should be there, should know what to do, and it might just be some tweaking some settings. Okay. So start some material. Are you guys ready for chapter 1 or what? So chapter 1, I can't even remember what it's called. I think it's just called Data Basics, maybe. Where is it? Introduction to Data. Surprise, surprise. So chapter 1 is called my writing is bad, but I'm trying. Yeah, so someone else is having that same problem where you've downloaded LaTeX, but then it's not doing anything. So maybe I'll try to see if I can find a solution there, and then I'll publish that. But yeah, RStudio Cloud, what's nice is everything is just installed already. And so that's what's really nice. It's a nice way to just get started and have it going. But you are limited with the free account. You're limited to the space that you can take. But honestly, I don't think that it would be a problem. So yeah. Introduction to data. So what I did was I have these notes that I used to use, and I posted them. I called them chapter 1. It's just a PDF that I posted on Moodle. Let's see here. Yeah, chapter 1. And it's just a summary of things that I want to talk about. And sometimes it saves us a little bit of writing, especially because my writing is so bad. So I'll pull chunks of this in, but you have the PDF, so you can do the same. It just saves us a little bit of writing at least. Okay. And sometimes I jump around because my thoughts aren't always the same every term, but pretty much. So introduction to data. First, we want to start and we want to talk about, okay, well, what is statistics? Let's start there, right? You guys are in data science, so you have a pretty good understanding of, at least you know that you need statistics. You might not know what statistics is yet, right? But you understand that, okay, it's going to be involved here. And I was thinking about the question from last day. It was a question that I got was, how does statistics play into data science? And it's a really good question. And to me, I kind of reacted like, well, it is data science. But what I landed on later was that all statisticians are data scientists, but not all data scientists are statisticians. So statistics is kind of a broader field, of course, but all data scientists use statistics, but not all statistics. right? And so there's going to be core statistics that you use. And so you'll be mini statisticians, let's say. Let's go that route. Whereas all statisticians would consider themselves data scientists as well. That would be my kind of take on it. So you'll be using a good solid chunk of statistics, and that will be your job. Okay, so what is statistics? Well. Just grabbing from paste here. And I do want to revamp these notes here, but for now, for today, they work fine. Okay. So statistics in its kind of most basic form is when we use data, right, from a sample typically, right? Now you're going to have data. You could have just tons and tons and tons of user data, right? That's a possibility. But for now, let's just focus on, okay, if we have a sample of data, so we have this kind of subset of data, and the goal is to learn something about the whole population. Okay, so there's a lot of terminology that comes with that, right? And so we're going to have sample information that we use to try to learn about the whole population. Okay, and so we collect a sample. From the population of interest. Okay. The sample has to be representative of the population, right? But otherwise, besides that, we can use statistics to learn about the population. We don't have to look at the entire population to learn about it, okay? And so as long as, as long as the sample is representative of the population, we can apply statistics. Okay. We can apply, maybe I'll say statistical methods. Statistical methods to learn about the population. From the sample. Okay. So we're going to talk about sampling techniques, and we're not going to go crazy deep into sampling techniques, but we are going to kind of brush the surface because it is really important. So one important thing here is that as long as the sample is representative of the population, right? That's a key assumption here. And unlike what most people think, is we don't collect the sample trying to match the population. The key here is going to be as long as our sample is randomly selected, then we can assume that our sample is representative of the population. So we'll talk more about sampling techniques. We will discuss sampling techniques later, but in general, as long as a sample is randomly selected, we can assume it is representative of the population. Of the population. Yeah. So we will talk about different sampling techniques, and so sampling is kind of its own field of statistics. So we're just gonna kind of talk about the key ones. But the one thing that I need you to remember is that as long as a sample is randomly selected, okay, that lets us assume that our sample is representative of the population. Okay, and that's when we can apply statistical methods to learn about that population. Okay, what's going on with these consumers, that type of thing. Okay. So if we have a sample, I think the easiest way to think about a sample is we've all worked with some sort of spreadsheet, right? Probably an Excel spreadsheet. So we have a pretty good understanding of what a spreadsheet looks like. So I'm going to refer to a spreadsheet where things would be on a spreadsheet to kind of help us nail down some of this terminology. So once we have collected a sample, we often store the data in some sort of spreadsheet. So we often store the data in a spreadsheet. Yeah. So imagine here, you've got your spreadsheet. Okay. Now, let's say I'll keep the same color for a little bit. Column number 1, column number 2, column number 3. Let's say that. Okay. Observation number 1, observation number 2, observation number 3, for as long as we want. Okay. Until, and maybe I'll introduce it here, observation number n. Okay, and so n, lowercase n, is what we're going to use to denote our sample size. N is the sample size. That's notation that we're going to use throughout this course. So that's your first task, is to lock that in and say, okay, if I see a lowercase n, then that's my sample size. And if you've read any articles or research papers, they would have n equals 31 or n equals 29 or something like that, and that is to denote the sample size. Okay. So that's your first thing to memorize. There's going to be a lot of memorization, but it's going to be worthwhile because we're going to rely on this terminology. Now, the fortunate / unfortunate part of statistics is that we use statistics in so many different fields, okay? But every field has its own preferred terminology, okay? So my job here is to tell you all the different terms that we could use and which ones we can use interchangeably. And then it's your job to know, okay, if I hear a term, then I could just as well use this other term or this other term. So in the beginning especially, it becomes really kind of tricky to keep track of this terminology, but the more we work through it and the more we work with it, the better it'll be. Okay. So one thing that we all agree on is that here, these columns, we call them variables. Okay, it's because the information in each column varies from observation to observation, right? And so these are all variables. Okay. And here in the rows, we have the observations. Observations. Okay. So it's important to keep track of these. Okay, so if I imagine a column in my spreadsheet, then that would be what we call a variable. Okay. And then here in just this kind of big area, right? This is where we have our data. Okay. So that's where we keep our data. So we have data that we recorded for each variable and each observation. There might be things like missing data, but for now, let's just assume that we have this complete set of data. Okay, good. So what we need is we need terminology to talk about these variables because there are two main types of variables, okay? And depending on the type of variable that we have, that's going to dictate what type of analyses I can do, okay? And so the variable, oh, my computer's doing something weird. Okay, I think we're still on track here. Okay, so the variable type will determine what graphs and what analyses are appropriate. Okay. What graphs I want to add in numerical summaries, so I'll add that here, numerical summaries. And analyses are appropriate. Okay. So your job as a data scientist would be to have a really, really good handle on, okay, if I have this type of variable, I can do these things reasonably, right? You don't want to be doing something weird with your data that doesn't make sense, right? And so that's why we need to work through this. And of course, we need to talk about what are these different variables that I could deal with. Now, so a variable in general, right, is a column in your data set. Okay, so a variable in its most simple form can be split into two different types. Okay, and for the most part, I'm going to stick with just these two types. Now, all of these types can be split into different subcategories, of course, but in general, we have two different types of variables, and that is a numerical variable or a categorical variable. Okay. Those are our two main types of variables. Okay. All data can be, or sorry, all variables, I should say. All variables can be classified, ironically, because it makes it categorical. Anyways, I'm getting ahead of myself, but personal funny. All variables can be classified as either numerical or categorical. Get myself some more room here. Further subcategories exist, of course, and there's tons of them. Okay, but for now, let's just focus on these two. Okay, many more subcategories exist, but we will focus on these two. Okay. Now, here's where it gets a little bit tricky, right? Numerical variables can also be called quantitative variables. Okay. Numerical can also be called quantitative. Okay. Whereas a categorical variable can also be called a qualitative variable. So it can also be called qualitative. Okay. So here, what I want you to think about it is quantity and quality. I'm going to focus on using numerical and categorical because for me, that points me in the right direction, right? And so from just the words, we can use those as clues as to what these variables are, right? And so for a numerical variable, it is exactly as it sounds. It's some number, it's a measurement, okay? And so numerical variables is a number or measurement. Okay? So some quantity, right? And so things like speed and time, and time is tricky, but it is in there. So speed, weight, distance, all those, would be numerical variables. Okay. Categorical variables or qualitative variables are also exactly as they sound. So you can use these terms to kind of guide you along, right? You don't have to memorize them. You can kind of get there on your own, and that's the easiest way to learn these. But a categorical variable is going to be anything where we have categories. For example, if I ask you what year of school you're in, first year, second year, third year, fourth year, that's kind of a tricky example, right? Because, well, they're numbers, but they're not measuring anything necessarily, right? They are categories, right? And so categorical variables is the data can be split into categories or can be classified into categories. Which can be numbers. Okay. For example, if I ask you, right, what year of school you're in, then you could say first year, second year. You guys are kind of special, but third year, fourth year. Right. these numbers are categories. Okay, so that can be a little bit tricky in the beginning. And there are cases where you're kind of on the fence. Is it categorical or is it numerical? Now, one little trick that I want to share with you guys is if you feel that it makes sense to talk about the average of something, then you can talk about it as if it's a numerical variable, okay? And so there are many cases where you're kind of in limbo. Is it numerical or is it categorical? Okay, so let me write that down. There are many variables. Oops. Show the R here. Well, I didn't. There are many variables that are hard to classify as numerical or categorical. So one trick that I use is you ask yourself, does it make sense to talk about the average? Okay, if it does, you can use it as a numerical variable usually. Okay, and so there are many variables that are hard to classify as numerical or categorical, but one trick, I'll say trick, it's not really a trick. We only talk about the average of numerical variables. So that's why I use that as a check-in point. And if you're ever unsure, then that would be your argument, right? I am using this as a numerical variable because it makes sense to talk about the average speed, the average distance, the average weight, for example, all those things. It doesn't really make sense to talk about the average year that you're in, right? So then it gets a little bit weird. You could, but it doesn't really make sense, right? Some simpler examples might be eye color or something, right? Brown, blue. Here, I can only think of two, I guess, green, blah, blah, blah. Anyways, there it's obvious that these would be categories, right? And so this would be an easily identified variable that is definitely categorical, right? Because we have categories, we have these explicit categories. This one is a little bit harder, right? Because we have numbers, but they're categories. So there are many variables that are hard to classify as numerical or categorical, but one trick you can use is to decide whether it makes sense to talk about the average of that variable. If it does, we would argue that that variable is a numerical variable. So if it does, we would argue that variable is a numerical variable. Yeah. Good. So that's kind of the trick that we use. Now, in the notes that I posted, there's a couple of, if we skip ahead a little bit, I'll come back to that. Don't you worry. But but I just want to bring in this flight data set so we can talk about it and talk about the different variables. Okay, so all the kind of definitions and stuff, they're also included in the handout that I posted. And so, but a little bit more concise, I guess, but here we talked about it. Okay, so let's have a look at this, a summary of this data set. We're not going to do all of these because there's no room on my page here. Let's crop here. So to introduce some variable terminology, we're going to consider the on-time data for all flights that departed New York City, which has 3 airports in 2013. So very specific population, right? The departures, I think, and the arrivals, oh no, so the departures from New York City, which we're including all 3 airports here, but in 2013, okay? And so there's lots more variables in there. In fact, there are 19 variables, right? And there's 336,776 observations. So here, our N is 336,776. This one's not a great example to kind of dig into because I would argue that that's the whole population, which we would use a capital N, but for now, let's just leave it as a lowercase n. It is the size of our sample, okay? So in terms of our spreadsheet, right, with 19 variables, what are we gonna have? We can imagine, right, 1, 2, 3, we would have all these flights up to 336,776 flights, right? And then we have 19 columns of data, 19 variables. The first one is the year, month, and day of the departure, the date of the departure. I actually can't tell. I think these are different columns, year, month, day. Year, month, day. Each flight, right, would be in 2013. Of course, we probably have data from other years, and so that's why we have the year here, but they should all be 2013, right? And then each flight is going to happen in a month, right? And on some day, also at some time, and at some airport, right? And so here, the departure time, oops, and so on and so forth, 19 variables. Right, so 19 total columns. Okay. And then our data would be in here. Okay. So, like I said, for us to be able to construct our analyses and kind of build a path where we choose what we do, we need to be able to identify, okay, which ones are numerical, which variables are numerical, and which ones are categorical. And that'll set us on the right path. Okay. So the year is not that interesting, so we probably wouldn't have it in our analyses because it's 2013 for all of these, right? But the month might be of interest, and I would say the month is what? A categorical variable, right? January, February, March, April, May, all the way to December, right? And so here, let's classify this one as categorical. the day is a number, right? But it's more of a category, right? The first day of the month, the second day of the month. We wouldn't talk about the average day, right? On average, flights took off on the 3.5th day. No, right? We wouldn't talk about that. So for that reason, I'm going to classify this as categorical as well. Okay. For the departure time and then also the arrival time, right? Here, I would maybe talk about these as numerical. Now, I could argue it either way. And that's what makes people uncomfortable about statistics is sometimes there is no exactly right way to do things. Your job is to argue why you did what you did, right? And it's as much of an art as it is a hard science, okay? And so what I want you to keep in mind throughout the course is, okay, as long as my arguments are logical, right? So they're based off of solid knowledge, then I can't argue with that, right? So if you tell me that, yes, it makes sense to talk about the average departure time, then there you go. Okay, you can use it as a numerical variable, right? If you argue to me that, well, I shouldn't say argue, but if you tell me that, no, it doesn't make sense to talk about the average departure time, for that reason, I'm using it as a categorical variable, I'm okay with that too, right? So here, the departure time and the arrival time, you could argue either way, okay? So here, these, we could argue either way, which people don't like to do, right? Especially when you're just beginning, but that is going to be something that you have to remember, right? How do you argue it? Well, does it make sense to talk about the average? Okay. There's the scheduled departure time and the scheduled arrival time, kind of same situation here, right? Whereas if we skip ahead to the departure delay and the arrival delay, well, those delays, it makes sense to talk about. So it definitely makes sense to talk about the average departure delay, the average arrival delay, right? And so, and we could talk about it for each airport, right? We could split it up by airport and we could split it up by month, right? And so we can do a lot of things there. And so here, these would definitely be numerical. Numerical, since we can talk about the average. Okay. So the time of the scheduled departure broken into the hour and the minutes, kind of irrelevant because I think we have the scheduled departure time. It just depends on if you want the hour and the minutes separately. And then the carrier is one of those obvious obvious categorical variables because it's a 2-letter carrier abbreviation. So for us, we basically only have WestJet and Air Canada, right? Or Swoop or Flair, or I don't know. We've got I guess we have a few, but not a lot, not like in the States. Right, but this is obviously a categorical variable, okay? Because we don't want to talk about the average carrier, right? That doesn't make sense. Okay. So good. So we need to be able to be given variables like this, either in a list or in a spreadsheet or something like this, where I can give you the variables that you have. And even just from the description, you should be able to classify the variables. Okay, so we should be able to classify variables by just using the description as we have done above. If we have the data, then that might be even easier, right, to use. And we can just look at the data and then that'll help us along, right? If I see numbers, then I'm going to think it's a numerical variable, but I don't want to be tricked, right? I want to make sure that it makes sense to talk about the average. Okay. Okay. So we need to be able to classify variables. That's our first task. Okay. And it doesn't help that there's all these different terms. So numerical data can also be called quantitative, and categorical data can also be called qualitative. So far, that's all we have. Okay. Now, we can further classify numerical variables and categorical variables, and I'm just going to introduce those briefly. It's not something I want you to focus on too heavily, right? As long as you have kind of the two main branches understood, then I'm happy with that. Okay, but we can further classify the two variable types. So here, right, I can have a variable and it can either be numerical or, and maybe I'll bump this over here, numerical slash quantitative, or it can be categorical slash qualitative. Some subcategories, and again, these are just kind of the main subcategories of a numerical or a quantitative variable. Is it can be continuous, meaning it's on a continuous scale. So if a variable is continuous, it implies that it's numerical, but also it means that you're restricted by your measuring device, right? You could get an even more precise answer if you just had a better measuring device, right? And so precision is only dictated by the device, and we could technically have measurements on an infinite scale, right? And so things like speed and weight, all weights exist on an infinite scale, right? But because we're restricted by our measuring device, that's what gives us, 2 decimal places or 1 decimal place, right? But with a better device, we could have better measurements, right? And so things like the weight or speed or distance. So a lot of our numerical data is continuous. Okay. Another option for numerical data is we can have discrete data. Okay, so it can be discrete, where it's still numerical, but things like age is the most common thing, right? So it makes sense to talk about the average age of some group, right? On average, these people were this many years old, right? But we never report age as anything other than a whole number, right? Now, discrete values can have decimal places, and that's where it gets a little bit weird to distinguish between the two. And I would probably classify all of those decimal places as continuous, but there are instances where it's not. But for example, let's see here. the number of, I guess, minutes it takes, right? That would, something takes, so time, that would be considered discrete potentially, right? Because we don't talk about, or maybe dollar values, right? Dollar values, we can have more decimal places, but in life, we don't have more than 2 decimal places for dollars, right? It's numerical because it makes sense to talk about the average dollar amount, but I would consider it discrete, right? Because we end at 2 decimal places, right? So things like age or dollar amount, right? So discrete values, exactly as the word means, right? It means that there's some, you know, essentially categories of numbers. Okay. I didn't define that earlier. I should have, but I didn't. Okay, so age 1, 2, 3, 4, 5, 6, 7. Those are numbers, but we can't have values in between, right? And so no values. I don't want to say that. Think of categorical numbers. Oops. That's how I do it. I don't know if that makes sense to you guys though. Categorical numbers, right? Age, only 1, 2, 3, 4, right? The dollar amount, restricted to 2 decimal places. Okay, right? Because we can only have down to a penny. Okay. Good. In terms of categorical variables or qualitative variables, we can have nominal variables. Nominal, which is, so our categories can either have some natural ordering or no natural ordering. And how I remember is the nominal has the no in here, right? And so that means there's no natural ordering. I don't count things like if you order it alphabetical, you can, right? But what we mean by natural ordering is, for example, going back to that, what year of school are you in? First year, second year, third year, fourth year, right? And so there's that natural ordering, 1, 2, 3, 4. What grade did you get in whatever course? A plus, A minus, B plus, B minus, right? There's that natural ordering regardless of which direction you go. Okay, so if there is natural ordering, we call it ordinal, right? Meaning there is some order, some natural ordering. Ordinal has natural ordering. Okay. So no natural ordering would be things like hair color and eye color. You know, there's no natural way that I would report those categories. Whereas ordinal, a lot of categorical variables are ordinal. The flight number, for example, from that data set we just introduced, I would say there's no natural ordering there, right? Unless you go alphabetical, but I don't really count alphabetical because that's just arbitrary. That's an ordering that I've applied, right? And so what we mean by natural ordering is that it would kind of come naturally, right? Whereas if you are considering the departure times as a categorical variable, it would be ordinal, right? Because you would start in the morning and then you would progress throughout the day. And so then I would consider it ordinal. all of these things take time, right? And especially because there's all these kind of, well, you could argue it either way type of situations. So that makes it hard. Okay. Okay. Trying to think here what I wanted to. So let's introduce this here. So I'm going back to the top of those notes there. Maybe I'll make a note before I do. So in statistics, we are going to, we need to be able to talk about variables. That's really, really important. So I want you to spend some time today and just kind of review that terminology and make sure that it makes sense. And we'll work on it too. But so we need to be able to talk about variables, but also there's in statistics, we said, okay, well, we're going to take information from a sample to try to learn about the population. But what that means is we're going to take, for example, the average of the sample to learn about the average of the population. Notice how we have the average from both parts now. Okay, and that's going to be the case for anything that we want to talk about. Is there's going to be a sample component and a population component. Okay, and so we said that in statistics, we use sample information to learn about the population. Okay. Which introduces that need to be able to distinguish between information from a population or information from a sample. Now, I've got little footnotes here. So a population is everybody or everything that we're interested in. Okay. And then the sample is a carefully selected subset of the population, right? We've taken a sample, which intuitively we all understand, hopefully. Okay. So a calculation or a number derived from the population, we call it a parameter. Okay. And so I want to highlight, maybe in pink here, the population is a parameter. Okay. So if, notice the two P's, right, that helps. Okay, so if I say, oh, the parameter that we're interested in, what that implies is that it's something from the population, right? So the parameter is from the population. Whereas if I talk about a statistic, okay, it's all starting to come together now, right? So if I talk about a statistic, that means it came from the sample. Right. And so now if we kind of go back to the definition of statistics, right, the field is, well, that's when I take sample information to learn about the parameter, right, the population. So there's this kind of back and forth situation where, okay, we have a sample. We don't know what the population is because it's often impossible to see the whole population at once. Right? Think about, killer whales in the world, right? We've got a pretty good handle on them, but there's no way that you could get a snapshot in time of every single killer whale weight, for example, in the world, right? But what we do is we can collect a sample that's representative of that population, and then we can calculate the average weight of that sample. So then we have a statistic. Oh, I thought I was in pointer mode and I wasn't. So then I have a statistic which I can use to learn about the population average weight of all these killer whales. Did it go down from last year or did it increase from last year? That type of thing, right? And so, so we use statistics to learn about its corresponding parameter. Okay, so there's this kind of back and forth. We ultimately want to know about the population. We have the sample, so we can, in theory, know everything about the sample, right? And it's pretty easy to do with software. So, so we can learn everything about the sample, but what we really care about is what does the population look like? How does the population behave, right? So we can use the sample to learn about that population. Okay. And so there are some common measurements that we're going to introduce, and I'm just introducing them here. We haven't talked about them, so don't worry about what they are yet. But we're going to be talking about things like the mean, the standard deviation, and the variance. Hopefully all those words are kind of ringing a bell. You've seen them at some point. Maybe you've even used them, but we will talk about them. But for now, I just want to show the link between the notation for a statistic versus a notation for a parameter. Okay, so for example, if I have a mean and that mean comes from the sample, what I use to denote it is an X with a bar over it. Okay. In general, anything with a bar over it means that it's a sample mean of whatever is below it. Okay. I guess I didn't say it. The mean is the average. Okay. So, and I use those two terms interchangeably, and it's good to just get into that habit right away. So if you see mean, think average. I say mean, you say average, doesn't matter, okay? So I use those two interchangeably, and so we're pretty comfortable with the mean already, although we usually just call it the average, right? But in stats, we call it the mean most often. Okay, so here, what I wanted to say was anything with a bar over it, anything with a bar over it denotes the sample mean of whatever is below. So X bar is the sample mean of X. Okay. And then of course my favorite is what's that? It's your average smiley face. Right? Sample mean is the average, so the mean is the average, and so anything with a bar over it means that it's the average of whatever's below it. So X bar is the sample mean of X. Y bar, some textbooks use Y bar, some fields use Y bar, that's fine. That's the mean of Y, right? Doesn't matter. Where things get a little bit tricky is for the population, what we use is mu. And this is a Greek letter mu. And maybe I'll change my pen size, so I keep forgetting to do that, but yeah. And if for some reason, you know, you're typing about these Greek letters, don't worry too much about getting the symbols. You can just type MU and I'll know what you mean. Okay. And same thing with, for the standard deviation, if it's from the sample, we use a lowercase s. for the standard deviation, and for the variance, we use a lowercase s squared, okay, which also shows you the relationship between the two, but we'll get to that. For the population standard deviation, we use sigma, so a lowercase sigma. And of course, sigma squared is just sigma squared. Okay. So there's going to be this connection between, okay, I use X bar, the sample mean, to learn about mu, right? I'll never know what mu is. I might have some hypothesis about what mu might be, right? But what I do is I use my X bar to learn about what mu could potentially be, right? I use S, the sample standard deviation, to learn about sigma. Okay, I'll never know what the population parameters are, but I can use the statistics to learn about the parameters. Okay. So lots of terminology introduced today, and what I'll do is I'll make the recording for the remainder of chapter 1, but now we have a really good handle, or at least 50 minutes worth of chapter 1, but now we have a good handle on the core terminology at least. So let me know if you have any questions. Otherwise, I'll see you guys on Tuesday, and I'll let you guys know what happens with the room booking, etc. But anyways, enjoy the video tomorrow and have a great weekend. See ya.